We have this question on the board here. We're given this polynomial f of x, x raised to the power 2 plus 3x minus 2, and then this polynomial p of x equal to x raised to the power 3 minus x raised to the power 2 plus x plus 3. We have to evaluate the product f of x times p of x. Is that okay? So we multiply these two polynomials. What do we do? Okay, look at our solution. We want to work on this now. I had to bring out the polynomials first, and then we have our f of x times p of x. Now you recall that we stated that the first thing we have to do is to get the product that will give us the highest power of the expansion. And we stated from the previous video that to do this, we pick the highest degree in f of x, pick the highest degree in p of x, and then multiply the two terms, the two highest degrees. Now if you do that, x raised to the power 2 times x raised to the power 3 will give us what? To give us x raised to the power 5. You know how we get that, right? You are multiplying the same base, so you pick one of the x, and then you add the powers. Multiplication law of indices. Very important, please. Be guided by that when you are doing multiplication of polynomials. Now we've gotten the highest degree of this expansion. It therefore means we now need to check for x raised to the power 4 term, x raised to the power 3, x raised to the power 2, x raised to the power 1, and possibly the constant. Is that not so? So let us go for the terms, which if we multiply them, we would get x raised to the power 4. So I'll put plus, open bracket, we go. I'll start. I'll pick x raised to the power 2 from here and ask myself, what will I use to multiply? Which term will I use to multiply here to get x raised to the power 4? I'm looking at this, x raised to the power 2 times minus x raised to the power 2 will give us x raised to the power 4. Because if you add their powers, 2 plus 2 will give us 4. Is that not so? So let's do that. X raised to the power 2 times minus x raised to the power 2 will give us minus x raised to the power 4. Remember, plus times minus will give us minus. I already stated in the previous class that when you are dealing with this, please don't play with your signs. Very, very important. Your plus, your minus, they are extremely important. Okay, now we are done with x raised to the power 2, multiplying this to give us x raised to the power 4. Let us now still go ahead and then look at this 3x. Can it multiply anything here to give us x raised to the power 4 term? And I can see that that is possible. Look at this. 3x raised to the power 1 multiplies this x raised to the power 3 would give us x raised to the power 4 term. Is that okay? You know, this is x raised to the power 1, this is x raised to the power 3. That 1 plus 3 will give us what? 4. So 3x times x raised to the power 3 would give us x raised to the power 4 term. Let's do that. 3x times this will give us plus 3x raised to the power 4. Take note, this is plus, this is plus. So if we multiply, we'll still get plus. And then I will now ask myself, the next term is minus 2. Can this minus 2 multiply any term here to give us x raised to the power 4? And the answer is no for what I'm saying. The highest thing that this minus 2 can multiply here to give us a higher degree is x raised to the power 3. It means that this minus 2 cannot produce x raised to the power 4. Therefore, we are done with x raised to the power 4 term. We close the bracket and add. Seek for x raised to the power 3 term now. Are we ready? We'll go back again. Pick your x raised to the power 2. Ask yourself, what will you use to multiply here to get x raised to the power 3? I'm going to be fast this time now, believing that you've gotten the idea from what I explained here. This x squared multiplies this x will produce x raised to the power 3. You know, this is power 2, this is power 1. So if you add the powers, you get power what? 3. Therefore, we'll go to multiplying x squared by this x, and that will give us x raised to the power 3. Next, I'll pick 3x here. This 3x can multiply this minus x squared to give us x raised to the power 3 term. Because this is 3x raised to the power 1. If that power 1, if you add it to this power 2, you get power 3. So let's do that. Plus 3x times minus x squared will give us minus 3x raised to the power 3. Then we'll pick this minus 2 and ask ourselves, can it multiply any term here to give us x raised to the power 3? And the answer to that is yes. If it multiplies this x raised to the power 3, it's going to produce x raised to the power 3 term. So let's do that. Minus 2 times plus x raised to the power 3 would give us minus 2x raised to the power 3. And so we are done with x raised to the power 3 terms. We now seek for x raised to the power 2. Let's do this. This x raised to the power 2 can multiply this 3 to produce 3x raised to the power 2. We are done with this. We move to this. 3x here can multiply this x to give us x raised to power 2 term. You know, this is x raised to power 1, this is x raised to power 1. If you add 1 plus 1, you get 2. So 3x times this x will give us plus 3x raised to power 2. You know, it's plus because this is positive sign and this is positive sign. Then we pick this term now, minus 2. Minus 2 can multiply this minus x squared to give us x raised to power 2 term. This is minus, this is minus. So minus 2 times minus x squared will change to plus 2x raised to power 2. We are done with that. The next we seek for x raised to power 1 term. Can this x raised to power 2 multiply anything here and produce x raised to power 1? It's not done because these are positive terms already, positive powers. And this is x raised to power 2 already. The power here is already greater than 1. So you can't use it to multiply anything here to get x raised to power 1. So you forget about that. This is 3x. What can you use 3x to multiply here to get x raised to power 1? 3x can multiply this x to give us x raised to power 1. And if you do that, you're going to get 9x. You're going to get 9x. Then lastly, minus 2. Minus 2 can multiply this x here to give us minus 2x. Minus 2x. Then the last expansion is the constant term. Terms that you multiply and there will be no x. And that can only happen when you multiply the constants themselves. So minus 2 times plus 3 will give us minus 6. We are done with the multiplication, so we can now simplify by adding or subtracting like terms. And good enough, the like terms are already in brackets. Is that okay? Now to add and subtract, recall we've done that from our previous class already. So let's go. This is x raised to power 5. There is no like term to read, so you have x raised to power 5 there. Come over here, this is minus x raised to power 4 plus 3x raised to power 4. Already we've done addition and subtraction, but let me just quickly show you what we do there. X raised to power 4 is common to both, is that not so? So pick their coefficient. This is minus 1 as a coefficient, as a multiplier of x raised to power 4. This is plus 3. Minus 1 plus 3 will give us what? To give us plus 2, is that not so? So that's going to be plus 2 raised to power, that is plus 2x raised to power 4. Come to this is x raised to power 3 minus 3x raised to power 3. We'll get minus 2x raised to power 3 here. That minus 2x raised to power 3 minus 2x raised to power 3 again will give us minus 4x raised to power 3. Come to this term, this is 3x raised to power 2 plus 3x raised to power 2. You get 6x raised to power 2 here. Add it to these 2x raised to power 2, that will give us plus 8x raised to power 2. Then this will give us plus 7x. Then plus times minus will give us minus 6. And this is how we solve this problem. Pretty simple. Let us now look at the second question in multiplication of polynomial expressions. We have these on the board. We have to evaluate x raised to power 3 minus x raised to power 2 minus 4x plus 4 times x raised to power 3 minus 2 x raised to power 2 minus 9x plus 18. Now, how do we approach this question? In solving, I had to bring out what was given to us to evaluate. Then, remember, the first thing by the method we are using is to obtain the highest power of the expansion. You see, this will help you to appreciate this method of multiplying polynomials. Imagine that you're to go by the general method of expanding algebraic expression where you use this to multiply everything here once, come back this to multiply everything here once, then at the end you start picking like terms, everything will be so scattered. Sometimes in picking the like terms, one might just even make mistake along the line. But by our method, the like terms will be arranged already and then it will be a straightforward work to do. Now let us do that for this question, okay? So the first thing we need to do is to get the highest degree in this expansion. And to get the highest degree, we need to multiply the highest degree in the first polynomial by the highest degree in the other polynomial. X raised to power 3 is the highest degree here. X raised to power 3 is the highest degree here. So x raised to power 3 times x raised to power 3 will give us, pick one of the x and then add the powers. 3 plus 3 will give us 6. You see, I've already encouraged you to ensure that you work with your multiplication of indices law, because that's what we really use here when doing multiplication of polynomials. Okay, now Since the highest power of the expansion here is x raised to the power 6, it therefore means we are going to check for x raised to the power 5 term, power 4, power 3, power 2, power 1, and the constant if they exist. Is that not so? So let us check for x raised to the power 5 terms, alright? Are we ready? I'm going to be pretty fast in that. So let's go. I'll start with this. This x raised to the power 3 can multiply minus 2x raised to the power 2 here, and you would get x raised to the power 5 terms. Is that not so? Look at their powers. This is power 3, this is power 2. If you add them, you get power 5. So I'll multiply x raised to the power 3 by minus 2x raised to the power 2. And that will give us minus 2x raised to the power 5. Good. This has done its work. I will go to this. This is minus x raised to the power 2. I'll ask myself, what will I use to multiply in this polynomial in order to produce x raised to the power 5? And you'll agree with me that minus x raised to the power 2 times this x raised to the power 3 would produce x raised to the power 5 terms. So let us do that. Minus x raised to the power 2 times x raised to the power 3 here is minus x raised to the power 5. Good. Then I would now move on to the next term. This and this have finished the work. I'll now move on to the next term, minus 4x, and ask myself, can minus 4x multiply anything here to give us x raised to the power 5 term? And I am saying no to that. The highest power that this minus 4x can produce if you use to multiply anything here is when it multiplies this highest degree. And if it multiplies this x raised to the power 3, it's going to produce x raised to the power 4. Is that not so? Good. Since this minus 4x cannot produce x raised to the power 5, it simply means this constant 4 cannot also produce it. Therefore, we have gotten terms in x raised to the power 5. We move on to those in x raised to the power 4. So let's speed up. X raised to the power 3 times this minus 9x will produce minus 9x raised to the power 4. Then, I'll come to this. Minus x raised to the power 2 will multiply minus 2x raised to the power 2, and it will produce plus 2x raised to the power 4. Remember, minus times minus changes towards plus. Then x raised to the power 2 times x raised to the power times 2x raised to the power 2 will give us 2x raised to the power 4. Then I will check for this. Minus 4x, remember we are looking for terms in x raised to the power 4 when we multiply. Minus 4x can multiply this x raised to the power 3, and it will produce x raised to the power 4 term. That result is going to be minus 4x raised to the power 4. And I guess that is all for terms that will give us x raised to the power 4 when we multiply them. This 4 cannot produce any x raised to the power 4 when you use it to multiply. So we'll move on to x raised to the power 3 terms. Come back again, this is x raised to the power 3. If it multiplies this 18, it's going to give us 18x raised to the power 3. Is that okay? It's going to give us 18x raised to the power 3. Then minus x raised to the power 2. Let's check if it multiplies minus 9x. It's going to produce plus 8 plus 9. It's going to produce plus 9x raised to the power 3. Then let's come to this now. Minus 4x. Minus 4x multiplying minus 2x squared will produce plus 8x raised to the power 3. And then let's check for this constant. This 4 can multiply this x raised to the power 3, and it will give us plus 4x raised to the power 3. Now we are done with terms in x raised to the power 3. We now check for terms in x raised to the power 2. Now we'll go back again and start. Use this x raised to the power 3. This x raised to the power 3 cannot multiply anything here to give us x raised to the power 2. It can't. So forget about that. Minus x raised to the power 2 can multiply this plus 18 to give us minus 18x raised to the power 2. Then minus 4x can multiply minus 9x to give us plus 36x raised to the power 2. And then this 4 can multiply this minus 2x raised to the power 2 to give us minus 8x raised to the power 2. And these are the terms in x raised to the power 2. Then we can now add it to terms in x raised to the power 1. You know that this x raised to the power 3 cannot produce x raised to the power 1. This x raised to the power 2 cannot produce x raised to the power 1. So we'll come to minus 4x and check if it's going to produce x raised to the power 1 here. And I agree with that. Minus 4x times 18 will give us minus 72. Minus 72x. That's what it's going to produce. Then we'll come to 4 here. 4 can multiply minus 9x, and it's going to give us minus 36x. Minus 36x. These are the terms in x raised to the power 1. So finally we are left with constant, which of course is this constant times this constant. 4 times 18 is positive, you know, so it's going to be plus 72. And that is that. We are done with the multiplication. The next thing is to simplify by adding or subtracting like terms. You see, good enough, by this procedure, the like terms are already grouped. So we start, this is x raised to power, okay, let me write the answer here. This is going to be equal to x raised to power 6. Then you come here, 2x raised to power 5 minus x raised to power 5 is going to produce minus 3x raised to power 5. Then we'll come to this, minus 9x raised to power 4 plus 2x raised to power 4 will give us minus 7x raised to power 4. Minus 7x raised to power 4 from here, minus 4x raised to power 4. Minus 7 minus 4 is minus 11. So this is minus 11x raised to power 4. Next, we come to this term, 18x raised to power 3 plus 9x raised to power 3 is going to produce 27x raised to power 3. That 27x raised to power 3 added to this 8 is going to give us 35x raised to power 3. Then 35x raised to power 3, 35 plus 4 will give us 39. So that is plus 39x raised to power 3. Times in x raised to power 2, let's check. Minus 18x raised to power 2 plus 36x raised to power 2 would give us 18. That is plus 18x raised to power 2. Now that 18x raised to power 2 minus 8x raised to power 2, 18 minus 8 will give us what? 10. 18 minus 8 will give us 10, so that is plus 10x raised to power 2. Then this is plus. But let's check what this bracket is going to give to us. Minus 72x minus 36x. Minus 72 minus 36. You know, the number will increase with negative sign there. So that's going to give us about 108. That is minus 108x. Now, if this bracket produced minus 108, that minus times this plus will change to minus. So this term is minus 108x. And then lastly, plus 72. So this is the value or the expansion when you multiply this polynomial by this polynomial.